This is a review of absolute value inequalities. What we're going to do is do a warm-up now so that we can get ready for epsilon delta proofs. So a little review. To solve an absolute value inequality, this right here means distance. So when you have an absolute value, we're saying our distance has to be less than 3. So when we did our absolute values for algebraic, we would say x minus 10, and it's between -3 and 3. That this must be less than 3, but also greater than -3 in order to be true. And then we would add 10, add 10, add 10, and we would get 7 and 13. So let's look at that. It's between 7 and 13. And if you put right in the middle, that would be 10. And if you look at it, that is 3 units away in either direction. So when you read this, what it's really saying is that x has a distance from 10 that is less than 3. It's this area here. So when we read this basic absolute value, we're saying x has a distance from 10 that is less than 3. It tells you, as you read it, what it means. So let's look at another one. Here it's saying our x has a distance from 5 that is less than 10. So x has a distance from 5, wrong color, from 5 that is less than 10. So if we put a little 5 here, that means our distance has to be less than 10. So that means we can go 10 units to the right, which would be 15, and 10 units this way, which would be -5. And so our answer here is an x value that is between -5 and 15. Let me show you this with Desmos. So if you look at this right here, this is our first problem. There's 10, and we can go 3 units to the right or 3 units to the left, but these are all the numbers that when we plug into this inequality will come out true. So if I were to plug in, not 7 of course, but if I were to plug in 8, 8 minus 10 would be -2, and that changes it to a +2, which is less than 3. 9 only has a distance of 1 from here, so 9 minus 10 would be a difference of 1. See, each of these, when subtracted from 10, tells you how far they are from 10. And that distance has to be less than 3. So if I plug in 11, 11 has a distance of 1 from 10, so 11 minus 10 would be 1, which is less than 3. 12 also has a distance that's less than 3. And 13 is the largest. So whatever number you have in the middle, that's just telling us where it's centered. So now we're at 8, and the distance is 3. I can move it over more. And so now we're centered at 4, as you can see. So whatever number that is, that works that way. Now, if we put it as a plus, so a negative plus 3, that means we're at -3. So on each of these, you want to look at it as the opposite number, because 2 take away 2 is 0, and that's where we're centered at, 0 distance from our number. Okay, and then if I change that, you can see it gets bigger. That number is 5. So now we're a distance of 5 to the left and 5 to the right. And if I make it 6, it just gets bigger. So 6 to the left, 6 to the right, and I can pick any numbers I want. So if I want my center to be 5 and I want it to be between -1 and 11, I would say that's 6 units to the right and 6 units to the left. And that's how the absolute values work. So to add that to the graph, we know it's less than. So these are actually open dots on our graph, right there and there, or they're parentheses, however you want to look at it. But our interval would be from -5 to 15. All right, so I want you to try this one. And then at the very, very bottom, I want you to create 2 absolute values for each of these. So what would the absolute value inequality be for this one? And what would the absolute value inequality be for this one? So hit pause and give them a shot now. So this is what you should have gotten. So again, if we read this, it's saying x has a distance from 7 that is less than 2. So our x's have a distance from 7 that are less than 2. So these are all the x values in here that have a distance from 7 that is less than 2. And then here you should have said, okay, well, it's centered at 2, and this one was centered at -3, so we got to put a +3. And then if you either count or you subtract, you'll see that it's 6 to the left, 6 to the right. So our distance from 2 has to be less than 6. So these are all the x values that if you plug them into this inequality will come out true. And then this one had a distance of 4. So this has to be the inequality for it. So again, if you plug any of these in, they will come out true, like -2. So that would be -2 plus 3, which is 1. Absolute value of 1 is less than 4. If you did -6, that would come out to be -3. Absolute value of -3 is +3, which is also less than 4. So again, we're just reading this as x has a distance from 7 that is less than 2, and that's how you want to read it. So to connect this, what we're doing next, what we're going to have is something like this. X minus 4, absolute value, is less than, and this is delta, it's a Greek letter. And so we already know that we're centered at 4. So just like before, our x has a distance from 4 that is less than delta. So that means we're going to go delta units this way and negative delta units this way, giving us 4 minus delta and 4 plus delta. And that is the interval that we will get off of that. So that's what we're going to be using it for next. Thank you.